Now, to get started in Unreal Engine 5 for creating this, blueprint that's going to allow us to be able to develop these palm trees, we need to first create one. But let's just talk about what it is. So a blueprint here, in this case, you can see I can drag it out. It'll have a number of components to it. In this case, it's going to have, in the one I've generated, there's a leaf. There is a coconut that looks like it's jammed up at the top there. It needs to be offset, and it has the pieces for the trunk up it. And you'll also notice it has a spline here. So it's a sort of self-contained piece. I can say leaf count. I can go ahead and change the initial pitch of it, the incremental pitch, incremental scale values. So there's settings and parameters that we're going to be setting up to be able to drive all this and get it to work. So let's create our first blueprint. I'm going to right click, blueprint class, and we're going to create an actor blueprint. Let's name that correctly, BP underscore, and it'll be for me PalmTree example. And I'm going to double click on that and open it up. Now, once you have this blueprint open, let's take a look at the different parts of it. So down the right hand side, we're going to have all our elements and parameters basically. So at the top here, these are the elements that are added to it. These are the components, I should call them, that are added into the blueprint. Down below are all our variables that we're going to be creating, and you're going to find all our parameters and whatnot for any given thing we have selected down the right hand side. Across the top, we have our viewport. This is what will be seen, just like when I dragged out that blueprint there a minute ago. This is what will be seen when you initially drop it in there. Construction script. Construction script is what we'll be using. So this is input from the user as they build the asset, the sort of the blueprint asset. Event graph would be used during gameplay. So this would be happening real time, and it would be triggered as the game is being played. We won't need that. We're just going to need the viewport and the construction script. So let's go about and start adding the components that we're going to need. So first thing we're going to need is the spline. So up in the components area here, click add. We're just going to do a search for spline, and we'll see spline. And so we can add that in, and we can call this maybe just path to give us a name for it. And so you can see it here. It has 2 knots in it by default, and we want it pointing directly up to begin with. So currently right now it is pointing along the x-axis, and we can see that here the location is 100, 0. And so we're going to change that, and we're going to set that to be straight up, maybe even set it a little taller, maybe 500 units up or something. So there it is there. Let's just go and hit compile. Now you have to compile to ensure that all the code has been compiled to be able to run. So I'm just going to save as well. And we can now see that when we drag that out, we get a spline. And this is going to represent where the tree is going to go. So next we want to go and add one of the tree trunk pieces, and we'll get the trunk working first and get that set up so it's functioning. So in here we can go in and add something called a static mesh, which is what we have currently imported would be a static mesh. Now, static meshes are great, and they're very handy for certain things, but in our case we actually want an instanced static mesh. This is the same thing as instancing or copying objects in 3ds Max. A copy, it's basically a new version of it over and over again, whereas an instance is the identical version of it. The instance static mesh is going to generate less draw calls on Unreal Engine when it's trying to draw the screen, meaning that we're going to be able to maintain a higher frame per second value. So we're going to go with an instance static mesh, and we're just going to call this, we'll call it ISM for instance static mesh trunk. And then over on the right-hand side, we can go about choosing what mesh that we're going to be loading in here. So I have the SM palm trunk that we can load into it. We can see that this is here now, okay? and we have it loaded in as our instance static mesh. Now we're going to want to have that added in. So I'm just going to actually drag and drop that and say attach so that our path and our trunk are parented to the default scene root, which is the item. Let's just hit compile. And you can see that we don't have a trunk. It hasn't actually added it in there. So we need to then do a little bit of coding to get that to work. So to do that, let's skip over to the construction script. Now, the way this works is everything has to flow out of this construction script area, out of the output of this. And it's got to be fired one after the other. Now, there's ways of being able to manage this to make it look cleaner. As you can see here, I have many sort of sections coming together. Now, this is going to be done with a sequence node. Essentially, the first one in the sequence gets fired, then the next one gets fired, the next one gets fired. And these all get fired in a row. In a sense, the for loop then fires this, could fire something else. But it's good to be able to organize these things right out of the gate because they can get complicated as you start to build. So I like to start with a sequence. And the sequence nodes allows me to be able to add pins, or you could right click and you can remove them if you want. But you know, let's build on this in this case. So we want to be able to take this trunk and we want to be able to add it in to the viewport effectively. We want to add it onto it. So we're going to drag out of that ISM trunk and we're going to say add instance, and we're going to drop that in there. And so you can see what it's doing is it's saying add the instance. What's the target of that instance? It's our instance static mesh that we set up. And we need to fire it and get it to fire. So I'm just going to hit compile and you'll notice that it crashes. So when we compile this, and I'd be careful, I just crashed. I'm finding an odd little bug in 5.6.1 when I'm doing this. You'll notice it throws up an error, and if you roll over the error, it'll tell you what is erroring. So it's looking for you know, some sort of input into the transform. Well, strangely enough, if I just simply right-click and say split struct pin, okay, and it splits out the transform, the rotation, and the scale, and hit compile, it will work because the values are in there. So it needed some sort of input, but as a test, let's see what this has given us now. So now you can see that we have our spline and we have the you know, ability to move that. You see it's moving with it, okay, the trunk and the spline. And if I go in and click on the bottom of this, you can see that the trunk isn't moving with the spline right now. That's because the location of the object that we've added for the trunk, it isn't have any specific setting other than 000 for a location, which is at the basically the default scene root because it's relative to it. So what we're going to do is we're going to find and try and set up where the position, rotation, and the scale values are going to be. So we're going to need to add those in there. So what I like to do is do some sort of gathering of data that I'm going to be using as I move along. So to do that, I'm actually going to add a sequence up above. You can say right click, insert execution pin before, and then, you know, then 0 is up at the top. We're going to do an area here. We're going to collect some information that we're going to need. And we're going to collect that down into some variables that we're going to store it in, and so that we can reuse that. And we can refer to those as we go. So one might be the path length. Now, if you notice, I've added this down into an area called the local variable. Down here, I hit the plus sign. And so for that reason, I'm actually going to put an L underscore, so I know it's a local variable when I see it anywhere. Local, it's hard to explain why a local variable, but it's more memory efficient at this point. So what type of value is this? Well, it's going to be a float value, meaning the path could be 100.25 units long, as opposed to just 100, which is an integer. So to get that length, I'm going to drag out the path, and we're going to need to get the length of this. So I can just, you know, drag out and start typing in, oh, look at that, len, and I get spline length. So that's pretty easy. So that gives us that. But This can't be fired. You can notice it can't be connected to anything. What I want to do is I want to be able to set this value. Now, if you drag this value out, you're going to get choices. Get, and that's going to go and get whatever that value is. And if I drag it out and say set, it's going to allow us to set that value to whatever we want. We want to set. Faster way of doing that is holding Control and drag out, you'll get a get. And holding down Alt and dragging out, you'll get a set. So in this case, I'm going to set that value, but I need to fire it here. So I'm going to drag that in. So the first thing that's going to happen is it's going to go get our spline length. And to clean this up, I want to double click on the path and just drag it up there so that I see where all my connections are going. You can end up with spaghetti. So work clean from the get-go. So that's the length of that. Now, how many of these items need to be along the path to fill the path up? So we know what the length of it is. Well, maybe we should also get how big the trunk is, and we should collect that. So let's go and get a local variable again, local trunk height, okay? And that'll be a float value again, because it's going to be it could be some point value. And so I'm going to go and grab that out, and we're going to get the bounding box. And so get local bounds. And get local bounds is going to create a min-max value for us here. And then what we want to do is, we want to be able to subtract one from the other. We only need the height. So I'm going to right click on min, because min is an XYZ value. I want to say split struct, and I can say split struct pin again, so that, I can just get those Z values. Now, what it's going to be is it's going to be the max value minus, I'll just hit the subtract sign there, and it'll find us the min value is going to get that value for us to how tall it is. And then we need to set this again. So I'm going to hold down Alt and drag it out, and we're going to fire that next, and we're going to set that to be that height value. So that's going to return that height value to us. Now, one of the things you need to be able to do in your code is check whether or not things are working, okay, and you're getting what you expect. Now, we can easily do this by doing print statements. I'm going to drag out of the end here and just say print, and this will be temporary. And what are we going to print? Let's just print whatever that value is. So this output pin here is returning the value of the set right now. And I'm just going to hit Control-Shift-S to save everything. I'm going to hit compile, and now you'll see it prints out. And as I move it, there we go. Sorry, moving the wrong thing. You can see that it's printing out how high that piece is. So it's 60 units high, okay? And we want to then divide the length of the line and know how many elements we're going to need, okay? So we can then divide one into the other and find out how many pieces are required. So let's maybe make another one and say, call it LNum trunk, so the number of trunk pieces. This won't be a float value. It's going to be an integer, so it's going to be a 1, 2, 3, 4, 5. How many we need? And of course, there's going to be a rounding thing happening there, because if the trunk piece was 50 units and the line was 101 units, well, there's that extra 1 left over. You can only get 2 in there, but that's fine. It's going to look good as it is. So let's do a division between these two. So let's take the length of it. I'm just going to go get a control drag, and I'm going to go get the height. And let's go in and divide the length. And so grab that. I'm going to divide the length. So that is going to be our division, divide. And I'm going to divide it by that. And we can go and set that again. Now, we don't need this print statement necessarily. Okay, we don't need that converter there. So I'm going to bring this out with an Alt, so that we can set it again, and we can set that and we can put that in. Now, if you notice right away, it put this truncate node. And that node is what is truncating it, because this is returning a float value and this needs an integer value. So the truncate's being added in to basically round out the number. Okay, so rounding it off. So let's check that idea, and let's take the print statement again. And in the print, let's print that. And this conversion node, by the way, this is an integer value. This takes a string, which is a word. So it's converting the number, the actual integer, into a string that's required. So I'm just going to save again, compile, and you should see now it's telling us 60, or 8, sorry. So if we were to do the math there, we would take our basic line length, which is length of 500, divide it by 60. We should have 8 of these being generated. Well, that makes sense to me. So let's get rid of that again. And again, be checking what your results are as you go. You can make the simplest error as you go in with these things. And then later on, you can't understand why it's not working the way you're expecting. And it was some simple error you made further up. So check as you go. It's no different than coding in any language. Check everything, all your logic as you go, and you're less likely to have a fundamental error happen with it. So now we want to try and create more of these instances, and we're going to need to spread them along the path a given amount. So we'll get to that next, and we'll figure out how that's going to happen.